Morning students. So in the last class what we learned, it was about dielectrics and then what are the effects of dielectric on a capacitance. What we concluded there was the capacitance value will increase when you have introduced a dielectric, but there was a difference in the potential when electric field was connected and then disconnected. That only was the difference. Now the chapter enhances like this, that you are going to study about capacitor in series. What's the meaning of series? Something connected one to one, like how you are being seated. If there are 3 students in first bench, then second bench, then third bench, I will be keep on counting from here till here. That is what a series is. So like that, if I am going to have 3 capacitors C1, C2 and C3 connected in series, when there is a potential V is applied. There is a potential V is applied. But here what will happen is actually each capacitor will have the same charge. The charge in C1, charge in C2 and charge in C3 remains the same. There is no change in it. So when C1 is going to change, and if I need to keep the charge constant, what does it mean is that the potential varies, because we have studied Q is equal to C into V, correct? So if you need to keep Q as constant, then either C to be kept as constant or V1. So here what happens is V will change according to C1. Whenever there is a change in the capacitors, then there is a change in the potential also. But the total potential V is equal to V1 plus V2 plus V3, summation, adding all the 3. So we know that Q is equal to C into V. So where I can write in the place of V1 it to be Q by C1, because Q is a constant. So V1 would have been where there is a change in C1. Then in the place of V2 you get Q by C2, and in the place of V3 you get Q by C3. So what can be removed as constant is Q can be removed as constant, which will be equal to, so 1 by C1 plus 1 by C2 plus 1 by C3. But my idea is to find out the total capacitance or the net capacitance when they are connected in series. So that is going to be equal to CS. So what will be now? V is equal to Q by CS. So equate on both the sides. Naturally what happens? Q on the both the side will get cancelled, and you get 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is in the form of an expression. In physics, you should know to write any equation in terms of sentence. So how can I write this? Is equivalent capacitance is what is the net capacitance is. So inverse 1 by, you get it in the denominator. So I can write it as inverse of the equivalent capacitance CS. That is when capacitors are connected in series is equal to the sum of inverses of individual capacitance. Sum plus is there. So you write equal to sum of the inverse. Again it is 1 by C1. So you write inverse of each capacitors or individual capacitors. That is what is capacitor in series is. So the same one you will study in your chapter 2, lesson 2, but it will be resistor in series.